I've received some inquiries on how to fill out this form. I know some of you are getting a little nervous how to submit it. So here is the form online. It looks just like this. There's areas, just click on them. First one, simple. Type in your name. Here's my name. The next one, project name. Let's look at the print. Down here on the title block, there's the name of the project, benchwork. So we'll go back to this and we'll type in benchwork. List of materials required. That's pretty simple too. We'll go back to the print. So the materials required. First off, look down here in the materials. It says aluminum or mild steel. We're going to use aluminum. And then over here, just above the title block, it has the list of materials and sizes. So we're going to need that 1 by 2 by 3 aluminum block, a hex bolt, and a 3/8 OD bushing. So let's go ahead and go back to our form, and we're going to type that in there. We're going to type aluminum block. We're going to type the hex bolt, and we need the bushing. Now you can make this as detailed as you want on the materials. All it is give you a direction. Do I have all the things I need? Okay, so step one, you know we're going to lay this out. If you've watched the video on this, you know that you're going to lay it out using Dicom. You're going to need a hammer, and you're going to need a center punch. So down here, process one. You're going to lay out and center punch all your hole locations. Step two, we're going to center drill all those hole locations. So let's go ahead and put in a center drill for step two. And here you're going to center drill all hole locations. And you need to figure out the RPM for this. So let's get our calculator out. If you remember, I gave you a formula for RPM. I told you, and I gave you another, at another time I'll tell you again, it's 200 surface feet per minute for this aluminum. So the formula is, for a cutting speed, is 200, right? So 200 times pi and all of that divided by the diameter of your cutter, or tool, your cutter. Okay, workpiece if you're on the lathe. So for this one, once again, as a calculator, we've got 200 times pi, 3.14, 628, and we're going to divide that by the diameter of the cutter. So the center drill, the end of it is like 0.125. So it says 5,000. So you're not going to get that faster if you remember from the max RPM on that drill press is like 1,700. So that's the max you're going to do. But you can go ahead and put it down here. It is 5,000 RPM. If you could get that fast, you could do that fast. Let's do step 3. Step 3, once we've centered all the holes, we need to start drilling in whatever. So let's take a look at our print. We're going to start with this first hole right here. You see it's a through hole, goes all the way through. Follow the leader up. You also see that there's a little note there that this is your bushing. You're going to press fit into that. So you're going to ream for your bushing to press in. You're going to be 375 at your top end to 0.3745. So let's go back to our list. We know we're going to have to drill. So we're going to have a 3/8 reamer, 3.38 reamer. But you can't just shove a reamer into where there's no hole, so you're going to need a drill. What size drill we're going to need? Let's take a look at a drill chart. There's 3/8 right here. It's 0.375. The next fractional drill down is 23/64. That's at 0.359, so that leaves you about 16 thousandths, a 64th under your finished diameter. So let's go back to this process. So we're going to need a 23/64 drill. Too many L's. And so step number 3, we're going to drill 23/64 at, let's figure out our RPM for that one. You remember the formula. We'll clear all this. So it is cutting speed 200. If you recall, I said that reaming for this aluminum was the same speed as the drilling. So cutting speed is 200 times pi, 3.14. There's our 628 again. We're going to divide that point by 0.359, which is the drill. You can see that's like 1750 RPM. Drill at 1750 RPM. Because there is no change in the RPM for the reamer, so we're going to ream 3/8 at, let's get our calculator out again, and we want to know same thing, cutting speed is the same, so 200 times pi. Oh, that is not right. 200 times 3.14. Oh, cutting speed times pi. Let's try it again. 200 times 3.14. Working faster than the computer went. 628. That's the number I was looking for. And we're going to divide that by 0.375. And it's saying 1674. $16.74 RPM. And we'll double check our print real quick to make sure that is everything. That's all we're doing, drilling and reaming. So we're good there. Now we're going to do the next process. We're going to drill and tap for this hole. And here it adds something. This is the symbol for countersink. So when a countersink to a diameter of 430 thousandths at 90 degrees. Countersinks can come in 90 degrees, they can come in at 82 degrees. So this is actually the countersink for 90 degrees is for all, usually if you're doing for a bolt, it would be for a metric bolt, because they're all flathead metric bolts are at 90 degrees. All imperial or English or standard SAE flatheads are going to be at 82 degrees. Just a little something there. So let's go back. We'll look at our next process. So we're going to drill and tap for that 3/816. So we're going to need to figure out what drill size we're going to need, and we're going to have to add that countersink. So let's look at that drill chart again. Down at the bottom of this drill chart, there is 3/816 is your tap, and it says it's 5/16 is the tap drill. So if we look at our print, they're calling out a tap drill 307 to 321. 5/16 is 0.312. That falls well within the center. So we know we're going to need a 5/16 drill. So let's go ahead and put down there we're going to need a 5/16 drill. Your 3/816 tap, and we're going to need a 90-degree countersink. So we're going to drill 5/16 through at, let's figure out our RPM, get our calculator out. We'll say 5/16, so remember RPM is cutting speed, 200 times pi, 3.14, divided by 5/16 diameter is 0.3125. So we're looking at 2009 RPM. So let's go ahead and put that here. 2009 RPM. We're going to countersink. To 0.43 diameter at, and I will tell you that when you countersink, you only want it to be about 100 RPM. Countersinks, counterbores, the slower you run them, the better the finish you're going to get. You won't find that written down anywhere. I just know that's what I've used. So there's drill, tap, countersink. Number 5, process 5. Let's look at our print, see what else we have left to do. We have one more hole to drill and tap right here. Looks like we got a 196 to 207 drill. We'll have to look that up on the drill chart. 880 deep. You notice it doesn't go all the way. I'm going to show you here this. The 880 is actually to that corner of your drill that has the largest number, not to the point but to the corner of that drill. That's where your 880 is. So 8.88. So it's 1/4 We're going to countersink to 0.28. Let's find out what size drill we need. Look at the drill chart, 1/4 it says number 7. Let's slide up here. It says number 7 is 201. So right here, 201. And that falls well within the 196 to 207. So let's go back on our, we're going to need a number 7 drill. We're going to need a 1/4 tap. Oop, didn't get my 2 in there. We don't need to call up the countersink because we don't need to have 2 countersinks. We only need the 1. So let's write our processes. We're going to drill 5/16. Let's see what RPM we're going to do. We'll do our calculations again. So we have our 200 times pi divided by our diameter, which was 201, remember? Or excuse me, this is number 7, isn't it? It wasn't 5/16, number 7. Number 7 at, let's look at our calculator. We're going to divide by 0.201. 0.201 was our number 7 drill. And that's saying it is 3,124. Go ahead and put the proper 3,124 RPM on there, even though we can't get that fast because our machine won't run that fast, but that's what it calculates to be, and that's what I'd like you to see. We're going to tap quarter 20 by hand. Oh, before we do that, let's put this in here. We're going to countersink. To 0.28. Then we'll tap. So looking at our print, we have completed all of these. The last thing we need to do is, it says here, note you're going to install that stud. You're going to cut it above longer than 130 and file it down to length. So we'll go back to our process. Number 6, we're going to need a wrench to install that bolt. We're going to need a hacksaw to cut that bolt off, and we're going to need a file to file it to height. So let's go ahead and put in process 6. We're going to install the hex bolt. We're going to saw it long, and we're going to file to 0.13. And the last thing we're going to do, we'll call this process 7, is we're going to stamp your initials. And the date. Well, stamp the initials and the year. In your block, so we're going to need a hammer for that. We've already got that, so we don't need to list that in the tools. And these letter stamps are already up there by the anvil, so you won't have to get those out. And then you're done. The only thing you have to do is pick up all your tools, put them where you got them, and turn in, well, when you're actually doing it. For this one, what you want to do is just save this as a file. I would like you to save it as a, so here I'm going to show you what I'm going to do. I'm going to go ahead and file, save as. So as soon as that pops up, my computer is mind-numbingly slow today. So I would like you to go ahead and keep the name process form, give it dash, and give it your last name. So I'm going to say Riggs, and give it another dash and say bench block. And then I'm going to go ahead and find a folder that you can find whatever is convenient for you. We'll just put it in the bench block folder, which I have one somewhere. So save it somewhere where you can find it. So I'll just go ahead and put it on my desktop for now. Then we get onto Blackboard. Under week one, there's a link. If you click on that in the week one folder for the bench block, it'll pull up and it'll ask you to submit the form. You can just submit it right there, and then you're done. It's just that easy. What do we got? 20 minutes. So hopefully that helps everybody, and y'all have a great afternoon.